All right, so now we are going to find the area of n rectangles. So we're going to combine a couple of ideas we've already developed. So first off, let's talk about the width of each rectangle. So remember, the definition is b minus a over n. This is the a and this is the b. So for my delta x, I'm going to have 3 minus 1 divided by n. So 2 over n is the width of each rectangle. So I need a number line. I don't really need the function so much as I need the number line. So here's the number 1 where I'm beginning, and I'm making each rectangle of width 2 over n. So I get to the next x value, I make the next rectangle of width 2 over n. Of width 2 over n. Okay, so now let's identify what these x values are. So this x value here is 1 plus 2 over n. Because I started at 1, took a step of 2 over n, so I get 1 plus 2 over n. Okay, so this x value here will be 1 plus 2 over n's. I know that's 4 over n, but I'm just going to keep it like this because I want to establish a pattern. All right, so the next x value will be 1 plus 3 2 over n's. Again, I make the rectangle of width 2 over n, and I'll get to the next x value, so 1 plus 4 2 over n's. Okay, I think you're getting the idea of the pattern. Okay, so I can't possibly draw all n rectangles because I'm doing it in general. I'm going to go all the way up to the x value of 3. That's where I stop building the rectangles. All right, so the last rectangle will still have the same width of 2 over n. So let's think about this a second. So this rectangle here will be 1 plus, and not rectangle, this edge point here will be 1 plus n 3 over n's, because the 2 over n's, because the n's will cancel, so I'll get 1 plus 2, which is 3. So this right here, this 3 comes from 1 plus n 2 over n's, which gives me 1 plus 2, or is equal to 3. Okay, so let's talk about what this edge will be. This will be 1 plus n minus 1 2 over n's. One less step because this is n. All right, so let's write out what the sum of using left-hand endpoints, using n rectangles. So r sub n will be this, left-hand endpoints, let's put L sub n, left-hand endpoints, n rectangles. So for the first rectangle, this is my number 1 rectangle, and I'm going to use the left-hand endpoint. So the width is 2 over n, and the height will be f of 1, plus. So for rectangle number 2 here, the left-hand endpoint will be this one. So the width will be 2 over n, the height will be f of 1 plus 2 over n, plus width of 2 over n. So for the third rectangle, this is the edge point I'm using. 1 plus 2 over n's, plus, and I continue on until I get to the nth rectangle. So for the nth rectangle, I'm going to use my left-hand endpoint. So the left-hand endpoint will be this one. So I'll have the width of 2 over n, f of 1 plus n minus 1 2 over n's. All right, so what I would like to do is write it as a summation. So let's get use a little color coding. I want to rewrite it as a sum where if I put in I equal 1, I get this term. If I put in I equal 2, I get this term. If I put in I equal 3, I get this term. And if I put in I equal n, I get this term. Okay, this is not as useful to look at as the last one is. So it's going to have a factor of 2 over n. And then I'm going to have f of, and I want to have something, so when I plug in I equal n, I get this expression. So we can see it's going to be 1 plus I minus 1 2 over n's. And we can stop there. All right, so let's do this again. the function's changing. The where we're beginning and ending is changing. We're using right-hand endpoints. So there's quite a bit in common, but there's lots different. All right. Always start with the delta x. So the delta x is the b minus a over the n. So 4 over n is your delta x. All right, so we need to start at the x value of 2. And then we're going to end at the x value of 6. And each rectangle is going to have width 4 over n. 4 over n is the width of each rectangle. All right. So again, identifying what this x value is and establishing the pattern is the big deal. So this will be 2 plus 4 over n, this edge point right here. So I make another rectangle of width 4 over n. And then this edge point right here would be 2 plus 2 4 over n's. So what I'm doing is I'm identifying what these x values are. Then I make another rectangle of width 4 over n. And then I get to this next edge point, and this next edge point will be 2 plus 3 4 over n's. All right, so we get the idea. And then we get down to here where this is the width of 4 over n. So this number 6 here comes from 2 plus n 4 over n's. The n's canceling, so I get 2 plus 4, that gives me 6. Okay, so that's this edge point right here. And this edge point here would be 2 plus n minus 1 4 over n's. All right, so now let's make our right-hand endpoints and with n rectangles. So the width of our first rectangle is 4 over n. So this is rectangle number 1 right here. So the right-hand endpoint is this one. So f of 2 plus 4 over n. Plus. All right. So then the width of the rectangle is 4 over n. And then I'm using, for rectangle number 2, I'm using this right-hand endpoint. So it's f of 2 plus 2 4 over n's. Then it's plus 4 over n. And I'm using for rectangle number 3, the right-hand endpoint, f of 2 plus 3 4 over n's. Plus, and I'm going to go all the way down to rectangle number n. So it's going to be 4 over n. And then the right-hand endpoint, I could use 6, but I really want to establish the pattern, so I'm going to use this. 2 plus n 4 over n's. All right, so now I want to write this as a sum, I equal 1 to n. And so I want I equal 1 to generate that, I equal 2 to generate that, I equal 3 to generate that, and I equal n. I equal n to generate this. So this is the nice one to look at. So it's always going to have a 4 over n. It's going to be f of 2 plus I times 4 over n.